Good morning. Welcome to video lectures organized by SSMRV College, an ISR initiative. SSMRV College, one of the premier institutes run by the prestigious RV group of institutions, have come up with a unique initiative to engage the students at the time of these unforeseen medical emergency caused by corona outbreak. As a socially responsible institution, we would like to connect academically with the students to make good the losses caused. In this connection, I, Dr. Ambika, working for the Department of Computer Applications, has posted a video on the subject Cryptography and Network Security and the topic Network Layer Security. Please watch the video till the end and like, share with your peer groups and subscribe to our YouTube channel. Thank you. Network layer security controls has been used frequently for securing the communications, particularly over the shared network such as internet, because they can provide the protection for many applications at once without modifying them. In order to protect the network, we use a protocol known as IPSec. IPSec is not designed to work only with the TCP as a transport protocol. It works with UDP as well. IPSec, it protects the entire packet presented to the IP layer, including the higher level headers. IPSec works from one network entity to another network entity, not from application process to application process. Hence, the security can be adopted without requiring the changes to individual user computers or applications. Though widely used to provide a secure communication between the network entities, IPSec can provide host-to-host security as well. The most common use of IPSec is to provide a virtual private network either between two locations, that is gateway to gateway, or between the remote user and an enterprise network, that is from host to the gateway. Some of the important security functions performed by the IPSec are confidentiality, origin authentication and data integrity, and the key management. Coming to confidentiality, it enables the communicating nodes to encrypt the messages and it prevents eavesdropping by the third party. Origin authentication and data integrity is imposed by providing the assurance that the received packet was actually transmitted by the party identified as a source in the packet header. It also confirms that the packet has not been altered or otherwise. The key management is handled by allowing a secure exchange of keys. It also protects against certain types of security attacks like replay attacks. IPSec suite can be considered to have two separate operations when performed in unison, providing a complete set of security services. These two operations are IPSec communication and internet key exchange. Coming to the first one, IPSec communication, it is typically associated with the standard IPSec functionality. It involves encapsulation, encryption and hashing the IP datagrams and handling all the packet processes. It is responsible for managing the communication according to the available security associations established between the communicating parties. It uses security protocols such as the authentication header and encapsulated SP. IPSec communication is not involved in the creation of keys or other management. It itself is commonly referred as IPSec. Internet key exchange, that is IKE, is an automatic key management protocol which is used for IPSec. Technically, the key management is not essential for IPSec communications, and the keys can be manually managed. However, the manual key management is not desirable for large networks. IKE is responsible for the creation of keys for IPSec and providing authentication during the key establishment process. Though the IPSec can be used for any other key management protocols, IKE is used by default. IKE defines two protocols, OACLE and SKEME, to be used with already defined key management frameworks, Internet Security Association Key Management Protocol. IPSec works in a transport mode. IPSec does not encapsulate a packet received from the upper layer. The origin IP header is maintained and the data is forwarded based on the original attributes set by the upper layer protocols. The second mode followed by the IPSec is known as a tunnel mode. This mode, it provides encapsulation services along with other security services. In tunnel mode operations, the entire packet from the upper layer is encapsulated before applying the security protocol. New IP header is added to the same. Now coming to the protocols, IPSec uses security protocols to provide the desired security services. These protocols are the heart of IPSec operations, for everything else is designed to support these protocols. The security association between the communicating parties are established and maintained by the security protocol used. There are two security protocols defined by IPSec: authentication header and encapsulating security payload protocol. Coming to the narration of the first protocol, authentication header, the authentication header protocol provides the services of data integrity and origin authentication. It optionally caters for the message replay resistance. However, it doesn't provide any form of confidentiality. The protocol that provides the authentication of either all or a part of a contents of the datagram by addition of a header. The header is calculated based on the values in the datagram. What parts of the datagram are used for a calculation and where to place the header depends on the mode of a cooperation. The operation of the protocol is surprisingly simple. It can be considered similar to the algorithms used to calculate the checksum or perform some checks for error detection. The concept behind the protocol is the same, except that instead of using a simple algorithm, it uses a special hashing algorithm and a secret key known only to the communicating parties. A security association between the two devices is set up specifying these particulars. The process of the protocol goes through the following phase. When the IP packet is received from the upper protocol stack, IPSec, it determines the associated security association from the available information in the packet. For example, IP address. Encapsulation security protocol provides the security services such as confidentiality, integrity, origin authentication, and optional replay resistance. The set of services provided depends on the options selected at the time of the security association establishment. In this protocol, the algorithms used for encryption and generating the authenticator are determined by the attributes used to create the SA. The process of the protocol is as follows. The first two steps are similar to AH as stated above. Thank you for watching. Have a great day.